Assalamualaikum and hi. My name is Muhammad Zakwan. Today, I would like to present an introduction of Overcurrent Relay implemented in transmission lines network. The design and implementation of overcurrent relays play a critical role in safeguarding transmission lines, ensuring the reliable and secure operation of electrical power systems. Overcurrent relays are essential components of protective systems that detect and respond to abnormal current conditions in transmission lines, such as short circuit and overloads. By rapidly identifying and isolating faulty section of the line, overcurrent relay prevent extensive damage to equipment and minimize disruptions in power supply and enhance the overall system stability. The primary objective of overcurrent relays is to detect and initiate protective action when the current flowing through the transmission lines exceed predetermined thresholds. These thresholds are established based on the system design parameter, including conductor capacity, insulation capability, and overall system coordination. In conclusion, the design and implementation of overcurrent relays are essential for protecting transmission lines from abnormal current conditions. This relay form a crucial part of the protective system, enabling rapid fault detection, isolation, and system restoration. The problem statement of this overcurrent relay. The design and implementation of overcurrent relay for the protection of transmission lines present several challenges that need to be addressed to ensure their effectiveness and reliability. Despite advancement in technology and understanding, certain issues persist in the field. These include accurately setting response thresholds to achieve optimal fault detection while avoiding false tripping, achieving selectivity and coordination with other protective devices to isolate faulty section while maintaining the uninterrupted power supply to the rest of the transmission line, and ensuring practical implementation through proper installation, configuration, and testing. That's all from me, and thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamed Hafizurrahman bin Zamri. So today I will explain a little bit review about this assignment. So we start with the classification of fault. So classification of fault can be classified into two main categories, which is symmetrical fault and unsymmetrical fault. The symmetrical fault occur when there is a balanced fault impedance resulting in equal fault current in each phase. On the other hand, asymmetrical fault leads to an even disruption of fault current among the phase due to varying fault impedance. Symmetrical fault are a type of fault that occur in power system characterized by a balanced fault impedance and equal fault current flowing through each phase. This fault typically involves short circuit between phase or a short circuit to ground with equal fault current in each phase. So next, asymmetrical fault, also known as unbalanced fault, refer to fault in power system where a fault current among the phase are even due to varying fault impedance. Unlike symmetrical fault, which exhibit balanced fault current, asymmetrical fault result in uneven disruption of fault current through the system. There are several unsymmetrical fault, including line-to-line fault, line-to-ground fault, double line-to-ground fault. This fault can disrupt the normal flow of current and create unbalance in voltage and current across the system. So next, we go to the overcurrent relay. Overcurrent relay are vital protective device used in power system to detect and handle abnormal current situation. They monitor current level and trigger protective action when the current surpasses a set limit. The main goal is to safeguard equipment and ensure the overall safety and stability of the power system. Overcurrent relay are categorized based on the operating feature and current measurement method. These clarification help in selecting the appropriate relay for specific application. So we can see there are 5 type of overcurrent relay, which is instantaneous overcurrent relay, inverse time overcurrent relay, definite time overcurrent relay, directional overcurrent relay, and differential overcurrent relay. Instantaneous overcurrent relay operate without any intentional time delay. They provide immediate tripping action when the current exceeds a preset threshold. These relays are typically used in situations where rapid tripping is required to protect sensitive equipment or critical part of the power system. The operating time of instantaneous relay is very short, typically around 0.1 second. Next is inverse time overcurrent. This relay have a time delay characteristic that inversely varies with the magnitude of the fault current. As the fault current increase, the operating time of the relay decrease. So next is definite time overcurrent relay. This relay have a fixed time delay that is independent of the fault current magnitude. They operate after a specific time delay when the current exceeds the preset threshold. Directional overcurrent relay. This relay not only detect overcurrent condition but also consider the direction of current flow. They are used to protect specific section of the power system by tripping when the fault current in the undesired direction. Lastly is the differential overcurrent relay. These relay are used for protecting transformer and other vital equipment by comparing the current entering and leveling the equipment. They trip if there is imbalance between the current indicating a fault. So that's all for me. Thank you very much. So I will pass to my friend to explain next.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hashimi bin Muhammad Imran. Today I want to present about the design and implement of overcurrent relay to protect the transmission line. Okay, we start with modeling and simulation. Okay, for modeling and simulation, the calculation premium of the full load current is what the CT ratio is based on. So basically, on the table is the parameter and the value used for design. The earth fault is naturally set lower than the current premium at full load, while phase fault is setting above the current premium at full load to locate the high impedance fault at earth fault. The length of the line is 100 km, and the power system parameter for both phase and earth fault are variable. So next is the description of the model. So the transmission line are 100 km long, 230 kV and 50 Hz frequency. The initialized model is of the relay and network using the MATLAB and Simulink program. The selected network simulates an Atlas spur transmission line that is graded to an analogous circuit with a 3-phase power source on one side and a load on the other. The simulation model current phase are colored blue, yellow and red. Residual current will flow to the earth when a ground fault occurs, but not in a face-to-face fault. So this is the simulation design used in the MATLAB and Simulink process. So basically, the station generation and load center are connected through the extra high voltage line when the generation legs are several hundred kilometers away from the load center. Due to the high rate of the overhead line failure between 83% to 86%, the transmission lines protection is a highly serious problem of the electrical power system. So the circuit diagram of OCR protection represented by the MATLAB and Simulink. So this is the result for the normal condition, which is there is no fault occur. If there is no problem in a medium transmission line, the output signal will be normal and the current balance will show as will be shown. So basically the graph is current versus time. The reference starting parameters are true to be this energized when a minor change is made to this parameter. The phase that apply to this situation is then regarded as having fault clauses. Okay, that's all for me. Next, I will pass to Muhammad Nazhan. Thank you.
Thank you, Muhammad Hashimi, for your explanation towards the result of design and overcurrent relay to protect transmission line. Okay, now I will continue to explain about the obtained result. By the way, my name is Muhammad Nazhan bin Azman Rahimi. My metric number is 2010927170. Okay, the first one is LG fault, which is the fault causes a higher transient or peak value in the signal of phase A compared to the fault-free system, as shown in the figure of single line to ground fault. Next, energy coefficient associated with each phase and ground are calculated, and this coefficient vary in the presence of an AG fault. The current signal of single line to ground fault AG is the output waveform for this fault. Next, LLG fault, which is in the event of an AG fault, the transient occurring in signal A and B and the zero line are more significant compared to the other phase, as shown in the figure of double line to ground fault. Next, the distribution of energy between each phase and ground is influenced and coefficients are computed accordingly. The output waveform of this fault is shown in the current signal of double line to ground fault ABG. Next, LLLG fault, which is a triple line to ground fault, occurs when all three phases are shorted to ground, as shown in the triple line to ground fault, where all the phases are grounded. Consequently, the output waveform exhibits an increase in the current value during the three phase to ground fault. The output waveform in this fault is shown in the current signal of three phase to ground fault ABCG. Next, line to line fault AB. The current output waveform during a fault where two phases are shorted together without any connection to the ground, and the fault location is detected as shown in the figure below, which is the current signal of double line fault A and B. And the last one is triple line fault ABC. The current output waveform during a fault where all three phases are shorted together without any connection to the ground, and the fault location is detected as shown in the figure below, which is the current signal of three phase fault ABC. Okay, that's all from me on the result obtained for this topic. Next, I will pass to Muhammad Bukhari to conclude about our topic. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Bukhari bin Amin. So today in this presentation, I will conclude all the discussion about the implementation of protection scheme under transmission line network. So for a conclusion, an implementation of an overcurrent relay and differential relay in a transmission line using MATLAB or Simulink demonstrated its effectiveness in accurately modeling and simulating different types of fault. The overcurrent relay implementation showed promising potential for ensuring reliable protection in transmission lines. Simulation of a 100-kilometer transmission line using real parameters and the TEDCO type was conducted in MATLAB Simulink. The simulation produced current waveforms for different types of faults, which accurately represented real-world scenarios. The simulation time depends on the complexity of the model, with more complex models requiring longer simulation times. It also was based on the simulation solver,
whereas when the simulation solver have a higher complexity level to execute the process of the simulation, so then the time required for the process to execute is more lower. So that's all for me, and thank you.